I'm just starting the recording. Okay, hi. So the time now is 8:30 and welcome again to another lecture of CS211. Thank you again for choosing to spend your evening together with us. So I'm going to start the screen sharing first. Okay, last Tuesday, I think we ended off at this slide, but before we go there, let's just do a little short recap. So the main thing we talked about was on advanced SQL, and for advanced SQL, the primary type of query that we were talking about was about subqueries. So the situation whereby there is a query on the inner, or rather the entire query is made out of two separate queries. There's one that is inside and there's one that's external. So and in that case, right, we call this a subquery. So this is a subquery where this is the inner query and this is the outer query. Okay, and we also look at a few conditions like not in. Let me on my head. Is somebody looking for me? Yeah, not in or in, and also some of the other conditions whereby I can choose whether I can filter off my outer query using the results of my inner query. Yep. Then later on we went to look at a very unique kind of a query which is called a correlated query, whereby in my correlated query, what that is accessed from my inner query comes from from a table in my outer query. And recall last week, or rather Tuesday, when we talked about this, we mentioned that for every single line, the inner query is going to occur. So for every single, let's say if I'm looking at 401, I would then select, if I'm looking at the first row, 401, rc.sid is going to be 401. And this inner query is going to be executed for rc.sid equals to 401. And this will occur for every single row that occurs. And this is a very unique case, which is called not unique case, but this is a query which is called a correlated query. It's quite easy to miss this. So yeah, again, also take some time to get used to it. And I think we ended off at this point where we talked about using so-called having expressions. So in this particular case, we will have a subtraction expression. So this was where we left off on Tuesday. Okay. So in SQL, we are able to carry out arithmetic operations as well. So we can do plus, minus, times, divide in our select operator. So the criteria is that we will be doing it in our select operator over here. What this query is trying to say is, I am going to, in a way, carry out a join. And this join will be in the instructor class. In the instructor class, I'm going to join between instructor and instructor. So I will have instructor, and I rename it to I1, and instructor in I2. In my join, my condition is that the workload of I1 is going to be bigger than the workload of I2. So that is the main condition that we need to establish. Okay, so in this instance, as long as my workload of I1 is greater than that of I2, I will have a separate row over here. I think on Tuesday we mentioned that this would give us at word 2.5. So that's and then if we were to join this, this would be Vadim 2, Prabhu 1.5, Liu Fang 1.5. I think I did a little bit of this last week. Vadim, this is going to be 2, Prabhu 1.5, Liu Fang 1.5. Yeah, I think that's it. Yeah, I think that's it. Yeah, so this will be, so I also have Edward, Vadim 2.5, 2.5. So this is going to be the result of the join. Okay. So if I were to, instead of doing it, having this, instead of having this expression, yeah, if I were to select I1 dot iname, I2 dot iname, I1 dot workload, I2 dot workload, this will be the result of my query. Okay. The next thing that happens is that my workload will be subtracted from here. So it shows that I1 dot workload minus I2 dot workload. And in this case, Edward Badim, I have 0.5 over here. Edward Prabhu, I will have 2.5 minus 1.5, which is 1. Badim Prabhu, so Badim Prabhu, which is here, 0.5. Edward and Liu Fang, so it's going to be 1. And Vadim and Liu Fang, which is 0.5. So this is how we obtain the final results. Any questions on this, or clear how we came up with this solution? So yeah, so this is the result of this operator that we see over here. Okay. Let's see, okay, that's good. Okay, before I go on, please remember to mark your attendance. Thank you. Okay, so the next thing, let's go ahead. So this was the previous query. So we already, what we want to find is the difference in workload between any two instructors. Okay, so let's look at the next thing. Let's look at calculating the birth year for each student. So assuming that this year is 2019, I have the age of the student. So the student age is s.age. So what I'm going to do is I will then select all my students. So this is essentially selecting my students from student S. But if I want to calculate the birth year, what I need to do is I know their age is stored in a column age, and if assuming this is 2019, what I will need to do is I will need to deduct this from the age and plus 1, okay, which is exactly the operation that I'm doing over here. So 2019 minus s.h plus 1, and this will be renamed as birth year. So I will end up with SID as name and age, and sorry, top age, birth year, sorry, birth year. So I'll end up with these 3 columns in my final query. So called the query lah. Yeah. Okay with this? query result. Okay, I missed the word query result. Yeah, so I'll get these 3 columns at the end of my query result. Okay, okay, I assume that everybody is fine. Everybody seems very quiet today. Is it me? But seems very quiet. But anyway, it's fine. Okay, so I am able to do also other aggregation functions. So for example, I want to sum the workload. This sums all the workload from instructor column, and this takes the average score of 211. Okay, let's try this together. So let's look at this. So if we were to run this query, so select average score from RC, where rc.cid equals to 211. Okay. So it gives us the average score. If I were not to have this, so just select score. So these are all the scores. So with that aggregation operator, it then gives us the average of all of these 3 scores. So it's still say pretty intuitive lah, pretty intuitive, yeah. So nothing out of the ordinary. Okay, so if we were to, the next operator, which is very related to what we did earlier, is this group by. So over here, we have the motivation is this. So let's say I have this course ID is 211. I can get it. If I want to find 285, I need to replace this by 285. If it's 365, I need to replace. So I need to keep on replacing this number, which is of course very irritating. So let's say if let's say I have 225, 228. So let's say I have the average score of 225. And I also want to find the average score of 228. Of course, you can do this one by one, which is quite time consuming. So what the next operator allows us to do is it allows us to do everything in one shot with a so-called group by statement. Okay, so what is going to happen is that I'm going to show you here how it works. So from RC group by CI. Oh, maybe I should do this. RC.CID. Yeah, so it gives me for each course ID what is the current average score that I have. So this group by operator is actually a very convenient operator because it gives us the ability to do this kind of operation to group certain objects by their common characteristics. Yeah. So let's say even if I want to do like minimum, you can also find the minimum score for each maximum. So these are the order operators that we can immediately, so by extension, be able to carry out. And all this is we are able to group by due to my CID. Yeah. So let's say if let's say I have RC here. So let's say I want to group by select max score. Let's say I want to find out each of the student what was the best scoring module. CID from RC group by rc.sid. So if I were to do this, so this will be the, maybe I should put that. Student ID, rc.student. So yeah, a bit going off script. Yeah. So it gives me the student ID, the maximum score that the student scored, and also which module did he score in. So it tells me that student 401 scored the best in 211 with a score 94. Similarly, I can also do this. Yeah, so this will give me the worst scoring subject of that particular student. Oh, can zoom into the SQL, sorry. Yeah, right. It's a bit small. Yeah. Yeah, let's do this. So hope this is clearer. Yeah, so going a bit off script. So what I'm doing right now is I want to find out what is the lowest scoring module of any particular student. So I am selecting the rc.sid, which is the student ID, the course ID, and also the minimum score from the RC table. I'm grouping by the student ID. Yeah, I also think, is it got bug or not? Let me check if my code got bug or not. 402. Oh, because he only got one module. Yeah, so his top is also the worst. So 402 only have one module. So oh, I can't do it back. So anyway, so it was so if you want to find the average score of that student, so I would have rc.sid and of course rc ag of rc.score from rc group by rc.sid. So you notice that actually once you are familiar with it, the query is quite intuitive. It's actually really quite intuitive. So once you're familiar with the syntax, right, you can write this out quite not very difficult to write this query out. Okay, so this is the group by operator. I'm going to go next. So now we are we are doing one level in, which is we are doing a group by, but the group by is a subquery. Okay. So what this query is asking is, can I get my average score of all my students? Okay. Can I get the average score of all my students or not? So notice that I think this was what I did earlier, the average score of the student, and this then comes with the average score. Okay, let's do this. If I were to do this query instead, select average RC score by RC group by. If I were to do this, this gives me the average score of all my modules. But that's not what the question is asking. The question is asking, what is the average score of all the students? So that the earlier query, right, was the earlier query is the average score of all modules. Okay, so select average score from RC. That is the average score of all modules, but that's not what we want to do. We want to do the average score of all students. And to do this, the first step we want to do is we want to calculate what is average score of each student, and then calculate the average score across all students. So this first part is my inner query, and this second part is my outer query. Okay. So yeah, so this first portion is my inner query. The second portion is my outer query. So let's break down one by one. Let's look at what the outer query is giving to us. So the outer query is giving to us the average score of every student. Let's see the code. So average score of group by RC.student ID. Yeah. So this is the average score of every student. Okay. So in the query, this is the subquery. And what we have is that we want to select average of average student score from average student. Like that. Yeah. So if we actually sometimes want to be very clear, what we can do is we can do this. So we first rename the result of my inner select statement as this, and then I use this to, and I rename my average as this, and I use my result for my inner select statement, and I dot to gain access to what is here. After explaining so much, I hope there's no bug in my query. Okay, fortunately no bug. If I explain so much and there's a bug, it'll be very embarrassing. So anyway, yeah, so what we have is, this is the inner query, and inner query, I am renaming my inner query to be average student. In my inner query, I'm also renaming this average of all my scores as AVGS. And what is happening is that I am selecting my inner query, which is AVG student, and taking my so-called the single column, which is AVGS, and calculating the average of this. Okay. So if we were to not have the outer query again, let's see what we get. So we get this AVGS here. So we are actually getting the average of these 5 values in this query. Okay. So if I want to rename this mean score, the mean score is this. Okay. Very good. No questions, so I will proceed on. Okay. So we went to do this earlier. So this was the first query. Yeah. So what I think what this slide is trying to say is actually break this down. So the numbers are a little bit different. So this is the inner query. So I showed this is the result of the inner query, and then I'm taking the outer query, which is the average, and this will be the result of the average of this. Okay. Any questions? Okay, no, very good. Okay, let's look at the next slide. Okay, return the students who fail more than 2 classes. So this is a very how to say, very common error. So whereby we put this aggregation functions in the where clause. So this is not allowed to. We are not allowed to do that. We can't put aggregation functions in the where clause. So yeah, so this would be incorrect. Another common thing is, or rather, what we should be doing is that we should be using a having operator. Okay, so of course we can do a join, but using the having operator will be a lot easier than doing the join, and the join is actually really not required. So it's somewhat a lot better to use the having operator in this instance. And it's quite important to note that your having operator is, first thing, it must always come with a group by. Okay, you don't have a having operator by itself, so it always follows a group by. That's the first thing. And the second thing is, as I said, always follow. So you don't have it before the group by. It must always be after the group by. Okay, so the having operator must always be after the group by. Okay, so this is the syntax of this having operator. So let's see what this operator, what this query is doing. So we are selecting SID from RC where score is less than 60. So if I don't have this thing, right, what I'm doing is that I'm selecting students ID which has a module less than 60. Okay, so if I don't have the final line, this is actually what I'm doing. And maybe I'm selecting the student ID, but in this case, right, it will go row by row. So there'll be cases like, let's say this is not 60, right, because I don't have anything below 60 there. Let's say I have 90 there. So I will have this that is being returned, this that is being returned, this, 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 this. And so it will end up with a lot of so-called repeat. Yeah. And so on. Okay. So with this group by, I'm actually going to group by this operator. Sorry, I'm going to group by my SID. And right now I'm going to, my entire condition is that I want to find students with less than, with module scores of less than 90, grouping them by the student IDs. And when I count these rows, right, it must be greater than 2. So this is how we read this query. Okay. So let's do this. So select SID. SID from RC. Where score less than, I think I'm going to use 90. So group by SID having count start. Let's just use 1. Yeah. So all of these people have 2 or more modules with the score less than 90. Okay. So this is how we read the query in this manner. And if you look at this, browse the data, right, you're going to see, okay, so we have 401 has 2 or more scores less than 90. Same with 403, same with 404 and 405. So this is how we read the query. Okay, good. Okay. So remember, you're having must come after the goodbye. Okay. So let's look at another query. This is even more convoluted query. So the first part of the query tells me this part of the query tells me the students ID with more than 2 modules below 60. So this actually gives me a list of distinct and unique student ID. So maybe it's 401, 403, 404, 4005. So this gives me the list. And what happens is that right now I'm going to use the SID in. Okay, I'm going to use my SID. So I'm going to, what this query is saying is that I want to find out for the students that in a way failed more than 2 classes, calculate their average score. Okay? So if I don't have this, if I don't have this entire thing, if I don't have this where condition, what I'm doing is that I'm just, I realized that my sound was on mute. So if you were trying to talk to me, I saw I couldn't hear you. Yeah, but I don't get any complaints. So I think nobody was trying to talk to me for the entire 30 minutes. Anyway, yeah. So yeah, I just realized that I didn't on my volume. So the what was I going to say? Yeah, in this where condition, what it's just doing is that I'm finding my average score of my students. So with my where condition, with my where condition, what is doing is that this filters out students with so-called 2 failures, and they only, for those students with 2 failures, I'm going to do a group by their modules, and I'm going to count the average score. Okay, so I'm going to show how this. So is this a correlated query? Okay, so no, this is not a correlated query. Okay, so yeah, so although we have RC here, but this RC in this case, right, is different from this RC, so this is not a correlated query. Okay, I'm going to show it. I'm going to show this is fine. So select SID average score from RC where SID in my super large query to find SID. And in my super large query, what I want to find is I want to select SID from RC where score is less than 90, and I'm going to group by SID having count less than greater than 1. Okay. Hope I didn't screw up. Okay, it's good. So these are the 4 people that have 2 modules, or 2 or more modules less than 90 marks, and then I'm going to take the average. So if I change this to maybe 2, Oh, I don't have. Yeah, so so I don't have anybody with more than 2. So 1 is the normal. Okay, let's look at the data. Maybe I can do it. Yeah, yeah, it's okay. Yeah, so I think this is the best we can do. Okay, so this is how the query works. Okay, so far. Okay, very good. So okay, so SQL actually has a very strong relationship with relational algebra. So for example, if we have let's say we have this union, it is very similar to the OR operator. Okay, union is similar to the OR operator, intersect, accept as well. Okay, maybe I tell you what. Let's go through one example. The examples. I think this will be a little bit clearer because I think like this quite hard to understand. So let's look at this example. So selecting SID from RC where CID equals 1, union with the other one. Actually, you can tell here it becomes quite intuitive once you use the union operator rather than yeah. So once you see the union operator written in this way, it becomes very clear. What we are actually doing is that I'm trying to get my SIDs of people that take 211, so it's 4001, and then SID for people that take 225. So we have also other IDs here, and then I'm taking the union of them together. Okay, so it becomes quite intuitive lah. Yeah, so yeah, quite intuitive once you see it written in the SQL query. Okay. So sorry. I think I can move on here. Okay, so let's say if I want to find the cities or agents that where they are in. Put it, the origin of cities the origin city of both agents and customers. So what I do is I can select the city from customers, and then thereafter union it with the cities from the agents. And actually, it's about the same concept. It's what we did over here. Okay, so this is the earlier one. We are taking from the same table, which is RC. This we are taking from different table, one from customer, one from agent, but they are still able to be joined together. Okay, then intersect. So we call that in our earlier part we went to do a statement like this, and we use the join operator in order to carry this out. We use the join in order to carry out this operation, but the same thing can be achieved with the intersect operator. Okay, so these two will be exactly equivalent, the same. Yeah, so either of these will be fine. And accept. So we have a few ways of doing this similarly. So in the last lecture we did on Tuesday, we talked about this operator whereby it's not equals to a certain number. And right now, we use this query in the last lecture whereby we have not exist. So there is a outer query and inner query. So the inner query, we use a join, and then we have a, let me see that. We use a join, and we use a join to say what are the SIDs that do not exist in this inner query. So similarly, we are able to do the except operator over here. Let's see. I tell you what. Let's go through this in a little bit more detail, because I think maybe I did not go through this the last time that well. So we are going to do the inner query first. Select star from RC, where so this, let's see, is a correlated query. So this is a correlated query. So for every single row, this inner query will be executed. Okay. So what is going to happen is that we are going to select 401, the first row, and I'm going to see whether did 401 take 211 or not. So if he took 211, then 401 will be here. And this one, because it is where not exist, this will return an empty set. Okay. And same thing, if I go into this next row, it will not return me because the CID is not 211. So this will not return me anything. So also so this will also be a 401, and this will return me an empty set as well. Okay. Okay. So for these two will both be the same condition, but at 403, what is going to happen is that we realize that select star from RC where CID equals to 211 and R1.SID equals to 403. This query does not return me anything. So this 403 does not is not in this empty set. So in this negative where not exist here, 403 is going to be returned in this query. Okay. So this is how we find out the students that do not take 403. So this is one way of doing it, which is a correlated query. But I think this is a little bit complex. So maybe an easier way to do it is, and then we also, so before that, we also say that we can't, this way is not correct. Yeah, so because we will not be able to, because let's say this query will also be returned, so this query is not correct. Okay. You see why? Okay, I'm going to show why. So if I were to select SID from RC where RC CID 211. Yeah, notice that although 401 has taken 211 before, but it doesn't show up here. Okay. Okay. So so this is not the right way to do it. So this is not the right way to do it. This is the way, one of the ways to do it. Today we're looking at the accept operator. So this accept operator is, I'm selecting everybody that took 211, and then I'm selecting all my distinct SIDs, and I'm doing a accept. This is actually also very similar to a not in. Okay, so I can also change this to a not in, where SID not in this entire thing. Okay, so far. Okay, just a few more slides. Not now. No, it's not now. So yeah. So this is ability for us to return. If one of your rows is now ability for us to sort of query for a null cell. The issue is that some how the null value is being operated on is not very consistent. So some operators, they count the null value as another row, but some of it ignores it. So I had to be very careful when we're using this. I believe average also doesn't also ignores it. So sometimes it is being counted, sometimes it's not being counted. Yeah. So just be a bit wary when you're using the null operator. There's also another operator called inner join. So we talked about this the last time. So we are able to do a left join. So in relational algebra, if you want to do something like this, we can do a left join instructor on the course, and this will generate out the left join for us. Okay. Okay. If all is fine, right? Okay. All is fine. Then I think let's do this. Let's take a 10 minutes break. But before we go for the break, right? I am looking at having a quiz next Thursday. Actually, is Tuesday too short a time? Yeah. Is Tuesday too short to have a quiz? If Tuesday is too short, then we have it on Thursday. Is it okay to have a quiz on Thursday? Okay, let's okay, then Thursday, then we have a quiz next Thursday. The format will be in online. What will happen is that I will release probably it is either on Socrative or on Moodle. But what will happen is that we will have our normal lectures for about 1 hour or so. We'll go for a break. When we come back, then we'll do the quiz. There are some regulations that need to be there. Yeah, Thursday. Okay, we have it on Thursday. But there are some regulations that need to be there. So, for example, right, we need the video cam to be on. Yeah. So just make sure that there's nothing sensitive around you or confidential around you. Yeah, that you don't want to show on the video. Yeah, so yeah, the rules are similar to that of online exam lah. Yeah, so yeah, so that's the thing. So yeah, so that's my only announcement. Will you come up with any mock quiz? Hmm. I can I think I can I think I can come up with a mock quiz I think I can come up with a mock quiz yeah. But yeah, I think I can come with a mock quiz. Yeah, I think I can come with a mock quiz. Yeah, so yeah, so okay. So to answer the question, yeah, I think I will come with a mock quiz. But I may not go through the mock quiz because I don't know got enough time or not. Yeah, so I may not go through the mock quiz. But yeah, so the topics will be until let's see how far we can until until today lah. Let's put it until today lah. Yeah, let's put it until today. Yeah. Okay. Okay. Yeah. That's for me. Okay. Let's put it until today. Release the solution for the quiz on Tuesday. I think should be okay lah. Okay. Let's target that. Let's target to have a mock quiz to be released. Let's say Monday, Tuesday. So if there's anything on Tuesday, you can ask me during the lecture. And yeah, so on Thursday will be the quiz. Okay. Yeah, so let's do that. Let's do that. Okay. Oh yeah, I should have paused the recording. Yeah. Okay. So the resume recording. Okay. So there was some question. So difference between accept and not in. Yeah, I think Mr. Jiang gave a good point. So except it returns distinct rows, not in returns rows, but it may have duplicates. But I think but another point you want to take note of is that accept is able to take into account so-called rows with multiple columns. So in essence, it is comparing the entire tuple, but then not in like is just comparing one column by one column. So you are unable to compare across different columns in not in. Yeah, so that's one of the big differences. But I would say accept seems to be not as. But I think both are fine. But at least for me, I've used not in a lot more often than accept. But I think both are fine. Okay. Anyway, we are going on to the next topic, which is views. This topic will be quite short together with integrity. So data in the table is stored in a file. So we have tables that are stored. So they are stored as physical tables here. So what we want is that we want to create a view, which is only based on the conceptual schema. Okay, the EC, the external conceptual mapping. Okay, so what it means is that the actual data resides in the tables, but we create something like it also looks like a table, but we call it a view. And why we do this is typically we want to sort of hide my table implementation from other, hide my table implementation. That's one thing. The second thing is that in the event whereby my tables they may change or mutate, I want to be able to at least offer some level of so-called continuity in terms of this not affecting anything that goes from here. So really, in the very unfortunate case whereby my tables may need to change, the connectors that come and query my views, they may not need to change very much. Whereas if I were to have to change my tables, then every time I touch my tables, all my APIs will have to be changed already. So this is, in fact, one very good reason why views are being used and employed. Changing the data in the table usually will cause the views to change. Changing the data in the views may or may not cause may cause the data in the table to change. And we'll see examples of that later on. So how do we create the view? It's very similar to what we see earlier as a inner query. So the inner query, let's look at what the inner query does. Oh, that is another. We'll do that query later on. So let's do the inner query first. So let's select instructor name. Query course. So I'm supposed to select instructor dot instructor name and instructor dot course dot CNAME and course dot credit from instructor and course where instructor.iid equals to course.iid. So this is the inner query. So if I were to run this query, I'll end up with this, whereby I have the list of the instructors with their course names and the course credit, and what the view query is doing is that I'm able to create a view based on this, and the name of the view is known as lecture. And right now, you can't see it here, but if I were to refresh, unfortunately, I don't know why I need to refresh this. You see that the views are here, and now my lecture view is here. So I can, in fact, do any query I want also on my view, where credit equals to 3. So you can notice that I'm now able to query my view as if it is like a typical table. So that's where the strength of the views actually come in, whereby once you have created a view, and once the data may be populated in the tables, the views may be populated, may be pushed and populated as well. And any query that you run on them, automatically you're able to act purely on the view, and you don't need to touch the tables. Okay, that's cool. So we created this view earlier. So if let's say this is I want to create a view of students from computer science department. Let's break down this step by step. So what this so this is a 3-tiered query. So 1, 2, 3. What this first query is just doing is that I want to find what is the name number 03. Okay, 03 refers to my department ID for my CS. So actually this innermost query is just doing that. It's just returning me 03. And this is telling me, find me all my students where my student department is in 03. Okay. And finally, we create the view of my students where my department of my student is in 03, which happens to be the department ID of my computer science department. Okay, so that's it. Okay, that's it for this query, this view. Okay, so so as this slide mentions, I'm able to execute queries on my views. So in this first example, it selecting everybody, or rather all my tuples whereby the credit is greater than 3. And in the second query, I'm selecting all my students from my view, computer student, where my age is less than 20. So this is the view that was created from student. I didn't create it in the PHP mining, but I think it should be quite explanatory. Yeah, so I can further on run queries on my view. Any questions so far? Okay. So this is just the example of how the query can be broken down. Is actually broken down. So the first query here is the query on my view. What is this query then? This query is select star from student, where student ID in this So this entire thing, it looks similar to this. This is the inner query of my view creation. So when I do this operator, what it does is that it will substitute my view with my query that was done to create my view. So that this actually means that this data is not somewhat the views are not don't really store the data as in like in the table form, but it will query the so-called the parent tables in order to extract out the values so as to be able to return the so-called the query result. And it creates this view which is renamed as T view, and the condition is being placed here. Okay. Yeah. And the last part is further optimization. Yeah. So yeah, we won't go into this last part for today, but this is just further optimization in order to get the results from this query. Okay, so let's go to the next slide. So just feel free to stop me if you have any questions. So the next slide is this. So this one we will do because this is an important, not important, but this is an interesting example. So I want to, let's look at this example by itself. So I'm selecting SID as name, the average score, the minimum score, the maximum score, and the count from student group by student ID. So what is this? What is this doing? Okay, let's do this query together. The code. I'm sorry. I'm sorry. Yeah. I'm selecting s.sid s.s name student s. So at least average of score, and I'm going to name it average as minimum of score, minimum s, maximum of score, maximum s, count from student s, and also my RC table, where SID equals to RC.SID by S.SID. Okay, so this is my inner query. So this tells me that Amy has 3 courses: the average score, the minimum score, and the maximum score. And this is the so-called the how what is going on in the inner query. So this view creates a view of this query results. So if I were to F create view stats s, so this would create the view. I don't know why I have to refresh this for my view to appear. Yeah, so very irritating. Yeah, so this is the view that comes up. Okay, So this view comes from my earlier inner statement. Okay, so far okay. So why did I take the pain to do this? Is because right, I am not able to I'm not able to update the query in this manner, or rather the view in this manner. So let's say if I want to select star, do I need this quotation? Yeah, I don't need. So let's say I can select star where count greater than 2. Yeah, so it gives me the so-called the people that has taken more than 2 modules. But let's say if I want to do an insertion, so into insertion I do update set APG equals to 85 where SIV equals to 401. So this is what is in the notes. Yeah, then it's an error. What does error say? Oh, unknown column. Did I screw up? Okay, let's AVGS. 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 Okay, let's try this. Okay, so it says that the column, the target table AVGS is not updatable. And why is it not updatable? The main reason is because it is a aggregation what's the aggregation function. Yeah, so it is the average score. So we are not able to update the average score in this manner. So in this case, the update function will fail. Okay, so these are something that you may want to take note of. Okay. Am I able to insert something into this? Actually, it is possible. So let's look at this. So in the next slide, I'm going to just type there. So let's say my inner query is select as. So I usually like to type in the inner query first, just to check that actually so this actually like doing things correctly. So create view department student of as name the ID as. So I'm creating a new view with these 2 columns, and I'm taking it from this result here. So my view has been successfully created. And let's say I insert into that student values. Okay, so unfortunately, in this case, it created well, but I'm going to do this again. I think I mentioned why. Yeah, so there's a duplicate key for primary. So remember, last time I told you why. Remember, in the last time we said that in the student, or rather in the primary key, you're able to have 1 value of now for empty for your primary key, but you can't have 2. So maybe I explain to you what's happening. The first time I did it, the very first time I did it, I could insert this gentleman in, and what happened is that after he was inserted in, because in the view, there is no specific scope primary key ID that is there. So if I were to insert something here, there will be no value for the primary key. So the primary key will be empty. MySQL has this specific unique situation, unique condition whereby it actually allows you to insert an empty primary key. It allows you, but you can only do it one time, in the sense whereby if you try to insert in another time, they will complain that there is a duplicate primary key. So the error that they are catching is that is a duplicate primary key and not a empty or null primary key. Okay. For MySQL, you can also insert a null primary key. But yeah, so that is the. But I just want you all to understand that this is actually what is happening and what the slide is trying to say over here. Okay. So by right, it should insert, it should reject, because the primary key in the student cannot be null. But I think it's interesting to note that for MySQL, it allows you to insert. And I think it's important for you to know that when I insert it into my view, it automatically also gets inserted into my table. Yeah, so I think that is actually the key takeaway part of this slide. Okay. Yeah. Then view modification. Some of these are actually not allowed. So aggregation function, you're not allowed to modify the views of these functions. So if you have group bys, select distinct, if you have aggregation functions, you will not be allowed to modify your views for these fields. Okay. So let's say we do another one. So this was what I was trying out during the break. I could get this done. So create view C start SID as name grade as select SID as name grade from student where the ID equals to 03. Okay, okay, let's just run this now. Okay, let's just run this. Oh, the first time I want to run it without. Okay, I know, at least I know the error here. So I usually run my inner query first, and the first time running without my inner query, I got a mistake. Okay, so I had an incorrect bracket somewhere. So now I have another view called C start over here. So this is going to be my my new my table, and I'm going to insert into C start. My code says step start, but actually it should be my C start. So I'm going to insert into C start values 408 and freshman. Yeah, so right now if we browse our view, okay, let me see my student. So this gentleman is now inserted in. How come it's not inserted in? Okay, I'll check on why my views are not automatically updated. This one I'll check for you. Oh, I know why already. Because unfortunately, although I've inserted, so actually this is an issue. And anybody see where the issue is? the issue is, okay, there's another question. There's another question. Yeah, so okay, so yeah. So can anybody see where my issue? Why is this not showing here? This view is only when my student ID is equals to 03. But when I insert it here, the ID is noun, so it will be not it won't be inserted in. Okay, let's try another one. Let's try another one. So again, I'm going to be adventurous and go off script. So let's try another one. Okay, Mr. Hong, I see your question. Oh, I'm going to revert your question later. So you bear with me for a while. So let's go to D, start, and now I'm going to have also DID. And now DID. So I'm going to do this. Okay, so now I have a new view of DID. You all know what I'm doing or not? Hopefully you all know what I'm doing. So okay. So okay, I'm going to do insert into this start values 4009 and this 10 freshman, and this one I have 03. Okay, let's try if this works. Okay, so this works. So student Tang is in, and Momo truth, yes. So now it's in. Okay. So so earlier when I inserted this, when I inserted the first, if you inserted this in, although I inserted into the view, but notice that it didn't appear in the view. Why? Because after insertion, right, the DID is equal to now. So if it's equal to now, imagine if I were to run the query, then remember in this, this view gets replaced by my SQL query, and if in my SQL query there, my DID is there's no value there, it's now, and so it's not going to be returned. So although I can insert it into my table, my view, but it gets directly inserted into the table instead, and it doesn't come out in the view. Okay, on this point. Yeah, so okay on this point. Okay, let's look at there's one question that was being raised. A little bit confused about the view. Is not only just at the but an update is not possible with the view. So your colleague asked about the update, and let's look at the update. No, it's not the. We can also do update. Let's update. Let's look at the update. Okay, so if you want to do update, let's do this. Let's say I want to update the name of Amy to last. So let's say update the start. So the question is that, do I mean to say all inserts can and update cannot? So I'm going to show what I mean. Set as name equals to let's say Amy, where SID equals to 401. Yeah. So let's look at this start. You can see that it is now Amy. So why? So the question it was that like why this one cannot, but this one can. Okay, what is happening is this. Let's look at set start again. Set start, right? The columns here, right, are actually aggregated columns, meaning that it's the average of few numbers. So because it's the average of a few numbers, right? So we cannot change the average. So let's say Amy, that's Amy. Amy is here. So let's say, so remember 86.5. Okay, let's remember this number, 86.5. And I'm going to insert. So insert into RC values. Oh, I got the syntax correct. Because again, I'm 365. Okay. Hopefully my syntax is correct. Yes. So you see 401 is almost full marks for 365. And just now remember it's 86.5, right? Now it's going to be 89. So my stats actually improve because there's a new row. So what it's trying to say is that I cannot manually update this by doing update. Because this is the aggregated column, is the number there is taken from the other columns from the parent table. So that's why I cannot do update here. Is that clearer? Okay, very good. Okay, so I think we are all very good here. Anybody has any questions? So the last slide for this is just delete lah. So drop view. So I can let's drop view. See start. Wait, before I drop, can you understand what I was doing? So okay, let me see. Okay, so I don't need that step. I don't need this, so I can drop. So once I do this, department statistics, department student is gone. Okay, so what I was doing earlier was that I first created the view, and from the view, I did some aggregation functions, show that we cannot update aggregation functions. Okay. And then after that, I created this view. At first, I tried to insert in a null, insert just this. Supposedly, primary keys cannot be null. So the first time I did it, inserted the empty primary key as a row, which is fine. The second time I did it, then it was rejected. Then after that, I went to create a C student, and I inserted this. And although I managed to insert this thing, but notice that it didn't appear out. And the reason it didn't appear out is because, although I insert this, but the department is still not equals to 03. And so it will not appear in the view because the view takes from the earlier query, puts it in, and does the query again. So it doesn't appear in this view. So what I did was I did the dstart, and then dstart I included also the department ID. And with that, I inserted a new row in my dstart view, and it is inserted in my original table, and it is also inserted in my dstart view. Okay. Any questions? Oh, okay. Okay, very good. Okay, I still have 5 minutes, so let's make use of them. Okay. Next thing we are going to. Oh no. Okay, yeah. I thought I forgot to record. Okay. Okay, I scared myself. Okay. Next thing is integrity. So integrity is actually we talked a little bit on integrity in the very early lectures, whereby we talk about want to ensure that the data is accuracy or consistent. Then maybe your data may not be consistent because of wrong input or wrong operations or whatever. So there are actually four components of that, which is your object collection, constraint, or trigger, your response. So it's a little bit abstract to talk about this like this. So I'm going to a bit more. Let's look at the some explanation. There are two types of integrity. One is static, one is dynamic. So static is, for example, age less than or greater than a certain value. So yeah, height less than greater than a certain value, weight as well. Dynamic, these are rules that you can set in. Salary can only increase, but it cannot decrease. We all hope that this is the case. So let's say if I have a salary that was 6,000 or 8,000, I can change from 6,000 to 8,000, but I cannot change from 8,000 to 6,000. Hopefully, this is the case in real life as well. So, how my spelling is like that? So constraint, it must be too sleepy. A constraint. So when defined, so this is the keyword constraint, and when defining a static constraint, so we use this keyword constraint. When we are defining an entity integrity, use the primary key, referential integrity foreign key. So what does this mean? Then actually, what does this all mean is that notice that so far in all my tables that I've done, right, I have not defined any foreign keys before. So when I do, remember in the very early lectures, right, when I talk about foreign key, I say that hey, if I delete away, if let's say this is 401 and this is 401, if I delete away this student and this RC, right? If I delete away this one should delete away as well. So this is a foreign reference to this. Remember in the first few lectures we talked about that. But actually so far, right, I have not shown this at all. Why? Because I so far in all our tables, I have not added in any foreign references now. So once we have the foreign references, then we can then decide what happens when you delete a certain role, and how should it react with all the other so-called rows or tables that we follow. Okay, that make use of that so-called referential integrity. Triggers will be something that will be that we will also be looking at, where a dynamic constraint is being violated. So when when this is being violated, then we may want to do something, and that will tie back to what we said earlier lah. So the response, the action when failed the validation, what then should we have to do when it fails this validation? I think I don't want to go into this now because it's almost time already. But this is essentially the foreign key constraint that we put in. And so this is the primary key. So this is the primary key. The foreign key is another one. So these are just two ways of defining the primary key. Yeah. So later on, after this part, we'll be talking about the foreign key. But I think I don't want to go into this code today. Yeah. Let's in a way let kind of stop at this point of time to take further questions. So anybody has any questions? I'm going to pause recording.